So writing equations for polynomials when given in zeros. We've kind of talked about how to write equations for polynomials when given as zeros or given as graphs before. For example, in this example, it says write the equation for the polynomial that has the solutions 2, 3, and 3i. Solutions means zeros. You may also hear it called roots or x-intercepts. All those different words for the same thing. Anyway, so we know what the zeros are. They're 2, 3, and 3i. But up until now, we haven't had one with imaginary solutions. So first of all, we know that if 2 is a 0, if I wrote the equation for it, it'd be y equals to x subtract 2 as a factor. And if 3 is a 0, x subtract 3 will also be a factor. But we haven't talked about those having as imaginary answers. So understand this. If we have an imaginary answer as one of our roots, x subtract 3i is a root. Also, the conjugate of that is the root. So if x subtract 3i is a root, x plus 3i is also a 0. And I'm going to just rewrite this again so I have more space. So here it is again. But understand this. I guess you make this as a note. If 3i is a solution, then its conjugate is also a solution. And basically what that means is, you learned a little about conjugates before. Basically the conjugate, if I said that x plus I is a solution, then the conjugate of that is x subtract I. It basically sets it up like the difference of two squares. You should have picked up that at some point by now, but basically that's what conjugates look like. If I said I plus 7 is a root, then the conjugate I subtract 7 is also a root. So those are what conjugates look like. So this is what you know. That's what conjugate is. So anyway, this would be the equation for it. However, we generally need to four this together to come up with the whole polynomial. So since part of this class requires you to actually know how to not only factor but also multiply polynomials together, you can four together these first two. So x times x and x times 3. So it's x squared, subtract 3x, subtract 2x plus 6. So four together these two. Because it worked like difference in two squares, x times x is going to be x squared. X times this is going to be positive 3ix. Negative 3i times each of those is a negative 3ix. And then the last part is negative 9i squared. It works like difference in two squared because this middle part is going to cancel out. You basically have the square of the first and the square of the last. So anyway, we combine it like terms. Y is equal to x squared subtract 5x plus 6 times x squared, these cancel, subtract 9i squared. What we know is from some other lesson is that I squared is the same thing as negative 1. So basically what this is negative 9 times a negative 1. So basically a negative 9 times negative 1, so it's positive 9. So what we now have is x squared, subtract 5x plus 6 times x squared plus 9. And again, the reason why it says plus 9, negative 9 times I squared means negative 9 times negative 1. That's what I squared is. So negative negative is positive 9. So this piece becomes positive 9. So from there, our last step would be to fold these two together. And since I'm out of space, I may as well write it over here. So rewriting that, y equals to x squared, subtract 5x plus 6 times x squared plus 9. And you kind of see that this is going to have the 0 to be positive negative 3i, because when you set that equal to 0, you get the square root of negative 9, which is positive negative 3i. But anyway, for this together, x squared times x squared times 9. X to the 4th plus 9x squared. Negative 5x times each is negative 5x to the 3rd and negative 45. And 6 times each gives you a positive 6x squared. I'm just going to line that up with other x squared. And a positive 54. Line that up with the 45. So if I combine my like terms, x to the 4th is by itself. Negative 5x cubed is by itself. These add up to be 15x squared. And these add up to be 9. So this is a polynomial that has those as its roots. So this is the answer for it. We can come up with an infinite amount of answers by multiplying everything by the same number. So a lot of other numbers could be, if you multiply all by 3, or multiply all by 2, or multiply all by negative 1, you get new polynomials with the same roots and different end behaviors and stuff, but still have the same roots. I think we could cover that as well. Anyway, that's how you write an equation for a polynomial when given its roots. Okay, so write the polynomial of least degree that has a leading coefficient of negative 2 and has zeros at 0, 9, and 1 plus I. There's a lot of vocabulary here. So the first thing I want to point out is the fact that it says least degree. That means that even though we can come over with a polynomial that's like x to the 6th power plus 3x, and they can have 6 zeros, some of those same zeros could be in the same polynomial as x to the 12th power plus 3x squared, and so forth. So I can come up with the same type of zeros, exact same zeros, but I can come up with a degree that's higher than that. Actually, I can come up with any degree that's higher than that. They have the same zeros. So since it's at least degree, just understand this. You want the degree to match the number of zeros. So basically, you want your degree to match the number of zeros. If you got 4 zeros, you should have the 4th degree, even though you could have 5th or 6th or 7th or 8th degree and still have those same zeros. So you just want to keep it simple. The zeros should match the degree. So anyway, and it has a leading coefficient, negative 2. I think we know what that is. So if you actually want to write this equation, I would start with what we know. Y equals 2. If 0 is the solution, x is one of the factors. If 9 is the solution, then x subtract 9 is one of the factors. If 1 plus I is the solution, then x subtract. Be sure to put 1 plus I in parentheses. That way you properly distribute the negative sign in each of those numbers. And what we just talked about was if 1 plus I is the solution, it's conjugate the solution. The conjugate of 1 plus I is 1 subtract I. So it's also a solution. So x subtract 1 subtract I. Then about to change sign of subtraction, just change the conjugate sign, and now they're still conjugates. So now you can fold together only 2 of these at a time. So x times x and x times 9. Well, that's x squared, subtract 9x. That's the easy part. And then before I start to multiply this stuff together and fold it together, make it a little less confusing by actually combining this stuff in parentheses. So this stuff actually combined, and this negative sign here, it means I have understood negative 1 there. So that negative 1 distributes in parentheses. And that makes this x subtract 1 subtract I. And same case here. It's understood negative 1 here. And that distributes into it, making it x subtract 1 plus I. Now I can begin folding this stuff together. I'll fold together these 2 first because magical stuff starts to happen. We multiply 2 conjugates, or these 2 things with i's in them. So x times x, x times negative 1, x times I. It's x squared negative 1x, and positive ix. And then negative 1 times x, negative 1 times negative I, negative 1 times I. I'm sorry, negative 1. Anyway, negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times I is I with a negative sign. And the last part, distribute I to all those. So I times x, I times 1, I times I. So negative I times x is negative ix. Negative I times negative 1 is negative positive 1I. And negative I times positive I is negative I squared. And this comes down. X squared subtract 9x. Combine whatever you can here. So I just rewrote this whole line all over again so I can kind of write on top of it and things and give you guys a good note. But basically my like terms are, this has an x and this is a negative 1x. This has an ix, this has another ix. This is an I, this is an I. This is a number. And this is also a number. I squared is really a negative 1. So let's go combine our like terms. So the first set is x squared subtract 9x. Here we get x squared, negative 1x, and negative 1x combined to be negative 2x. And positive ix, negative ix, come out to be 0. Positive 1, and well, better yet, negative I and positive I come out to be 0. And positive 1 and a negative I squared, where negative I squared means negative, negative 1. Positive 1. So this is really positive 1 and a positive 1. So it makes it plus 2. So great, all those i's are out of there. And now we got to fold these two together. But you know what? You should just pause the video and you fold them together. I'll give you the answer in a few seconds. So pause the video, get down everything you need to get down as a note, and actually try to fold that together on your own. So the probably number should wind up being x to the 4th, subtract 11x to the 3rd, plus 22x squared, subtract 18x. You can check it through to see if those solutions really work, but that should be the solutions for it. Well, that's all I have. That's pretty much all I can tell you about using the zeros to actually write the equations for the graph. All right, so with that being said, good luck.